This is going to be simple operation. It's already 1.5 inch diameter. I'm drilling inside 1/4 inch right through, and I need 2 pieces of that to go in the milling machine after and do some complementary work. So just drilling. I need about 2 inches, about 3 inches of that, a little bit more. Okay. Diameter inside can be 1/4 inch. Doesn't have to be bored or anything. Okay, we'll do a split before we do the rest. Let's use the cut-off tool. Okay, this will have to be faced, so I'm gonna touch with this, make myself a 0, and this measures 1/18. Okay, make another 0, and oops, 1 inch. Let's say I need 1 inch and 3/8, but I'll make it 1 inch and 450. It will give me place for refacing the other side. I know I'm sticking out a lot, but we'll make it so we go easy enough. If not, you're gonna see a nice accident. And while I'm at it, I'm just going to break the edge on this side. This is a finished side. So far so good. Not too far from the center. That's it. One done. Just to make sure we got a clean surface. Super nice. I always take the habit of removing my tools so I don't get hurt on it. I can feed a little harder this time. Oops. As long as you feel the little curlies coming out, it's okay. Sometimes, you know, they'll feel the jam. Just use stop before it turns bad. There you go. That's what I needed. Okay, we face the other end of this, and we got a super nice surface finish and everything. So let's chuck on it. inside joke. I guess someone will know what I mean. I thought it was funny. Okay, nice final cut. At about 6-7 thousandths to remove. Going slowly enough not to leave marks. You know, it's a pretty sharp, high-speed steel cutter, so it makes a nice nice cut. Usually, sometimes even nicer than carbide, but nice enough. Break the edge. There you go. This is a high-speed finish, and this is carbide finish. My appreciation here, high-speed finish is a little bit nicer. I don't know exactly what you can see, but that's it. And within 1,000, that's good. With those two cylindrical parts, I want to make holes, bore holes, like on the top there, down to insert this one, the bigger one, and one for the smaller one. I'm going to install them both in the vise. There may be, you know, if there is 1,000 difference in the length, I just still have my sandpaper there to make up for the difference. They're leaning on the you know, the parallel bar in the bottom, so they match up. I mean, it's slightly loose, but if I try to, you know, it's some kind of just a slight fit, so there's no problem with that. And I'm going to remove the bar just in case I go through and I don't want to catch sorry, and then mill on this. And to make it simple, I'm going to I don't want to do the setup twice and find the center twice and everything, so I'm going to feel, you know, on each side. This is a carbide and mill broken, this the shank of it. I'm going to be using the a feeler gauge. There we go. On each side, that's going to be a 0. Okay, lift this. I'm going to go on the other side and do the same thing. Okay, let's go by hand now. And we don't care about the feeler gauge because it's going to be in the middle of this. Okay, I'm going in the middle of this. 1.757. We're going to be about with 1,000. These parts are about within 1,000 tolerance on the outside diameter, so we're not going to be worrying too much about that. So I got the X calibrate. I'm going to calibrate the far end of the far end there. I don't want to you know, take into account sandpaper and things like that. So we're within about, let's say, with maybe 1,000 tolerance on the length, so we're well within reasonable tolerance. I'm going to use a 10,000 gauge here. Oh, I got stuff in my way. This is not a good week. Cold, flu. Okay. Since I've got the half the diameter of this 250 plus the 10,000 the feeler gauge, I'm going to bring the DRO to 260 just to show that it makes sense. So that's going to be my 0 point on the y-axis. So from there, going back to the middle of it, this is middle of it, and we're going to go like this is 1 and 350. So 1 and 350 is 675. So going 675 like this. So does it make sense? Yes, pretty good. Then we're going to move 750 on each side. Will be centered. Then we'll just bore the bore down. And now I'm centered over the first one. 750 on this side, half the diameter of the cylinder, and I'm going to be doing the same thing on the other side. I just put the center drill into a collet, so this way very solid. Let's center drill this. Okay, 750 on the other side, unlock the table. I usually get within 1 or 2 tenths, which is kind of a reasonable precision about this. We have 2 different size holes to bore in this. One is 8, I think it's 837, the other one is 1 inch. I'm going to be using carbide end mill, it's a 1/2 inch, and I'm going to go 1 inch 150 for the 250 for the first hole. That should dig. That seems good. A little bit of a almost there. That's it. First one done. Okay, this is the 1 inch hole. What I did put end mill, 1 inch, 2 flutes, running about 700 RPMs, and we'll go in slowly. This one will go only 1 inch and 150,000. I don't want it to show up on the other side. We're at 350. The only problem now, I guess you see it as well as I see it. We're at 500, but we're cleaning up. We're at 750. 850. There we go, that should be it. Now we got the other one to make, which is 837. This runs a risk of being a little bit more complicated. Okay, we're installed for the second hole now. This one is probably going to be done in 2 steps. I don't have anything that gives me like 837 in one shot or 835. So it's a 3/4 end mill, 2 fluted, and we're going like the other one, digging for an inch and 150. Just hope Mac doesn't see my my hair count. Okay, we're at 300. 1 inch, 150, that's good enough. Let's get that down. Okay, let's find a way to get from 750 to 835. Okay, the approach to get 835,000 this second hole is the boring head. I already got my boring head at 750 just to touch the sides of the holes. I haven't moved anything from the end mill, so it's still centered perfectly. Seems to be going good. I know I should not do that, but I'm end feeding. I'm still having a few little problems with my quill feed. So that's it. Just a little bit more to go. Okay, that's at the bottom. Now we'll check the size of the hole. Guess what? The little ball that flew right in there. Fuck. Always the wrong place in the oil directly. Okay, after taking one measurement, we're at 779. It's less than anticipated because the end mill that I used the first time was a reground and wasn't 750. So let's put this to good use. Okay, we said 779 and 89, 99, 809, and if I'm right, 819. If I'm not, we still have margin. Let's go for another one. A bit of a yeah, we're in the bottom of this. Another measure. Okay, we're 826. Okay, so we need another 10,000. Okay, let's check this out. I think that should be pretty well. Okay, let's move that out of there and we'll try this on actual material. After that, gonna be too late to do anything. Okay, this one, pressure wise, it's going right in. Perfect. Exactly what I needed. The other one, okay, this one fits perfect too. There you go. We're one step, more advanced in the construction of that. Okay, these are going to be quick shots. What I'm making now is weight. This is cast iron. I'll leave the surface kind of rough, doesn't really matter, and like another size and smaller one. So there's one in the lake now. See how we cut a 3/4 of an inch bore into the cast iron. Noisy and grainy stuff. Okay, naturally you cut cast iron with no oil, no liquids at all. It's lubricating itself. The only problem is it's messy. And this is, by the way, one shot that you probably never got before, because I'm using the crane with a temporary weight, just like the head of a sledgehammer that just keeps it balanced. See, you can move it, like just about a few directions, like that. It's about over my head, and can go up. The camera is about 7 feet in the air now. It stays balanced. Not bad at all. Okay, now we're making a thread. It's 3/4 of an inch, 10 TPIs. I've already done a few passes on it. I gotta go. I'm going right straight in it, no angle at all. Now I'm going to go 74. I gotta go 130 thousandths, and running 400 RPMs. The faster you go, the better it is. 79, 90. Oh, put a little bit of oil. The numbers are coming pretty fast at that speed. The N2. Okay, 104. Cut's getting a little heavier. Tip is super nice. 130. Don't got the feeling we're there yet, even though we should be. Now we'll give it a little spring pass. Maybe 2. Maybe 3. Okay, let's check it out. Oh, this is hot. Shit. Yeah, that's about it. Oh, still got more to go. We're 704 and we need to be between 683 and 677. I think this could be a nice spring pass and we should be fine. Okay, 687. Still got about 4 thousandths to go. And the spring pass. Okay, let's take a little measurement. Okay, 681. We're between 677 and 683. That's a perfect tread. And last, a little Scotch Brite. I'll make a soft tread. I think that should be clean enough. Gives you an idea of a finished product. And just to make a little test. Oh, it's easy, nice, no slop. It's got about maybe 2 to 3 thousandths, maybe 4, which is a normal class 2 finish on this. No bind. There you go. This is the weight system. I made this part here with a piece of aluminum. It's 1 inch thick, about, I don't know, maybe 4 inches this 4 or 5 inches this dimension. There's a 1 inch hole that's been bored to hold to the top pole. This is a 3/4 inch hole that's used to press fit the single pointed screw I did. It's a 3/4 inch screw with a 10 threads per inch, you know, like 10 threads per inch, yeah. And these weights, cast iron, just a big lump I had and cut into pieces to give me different weights and combinations I can do. This is like a counterweight adjustable, just to fine-tune the camera weight. And here, to make it secure on the top pole, the hole was bored 1 inch, and also I just used the bandsaw to cut a slot in it, and I nested the screw there. That's a 5/16 18, like just to really make it tight on top of this.